So hello students, after completing the size orientation matrix and the like LOC based and function point based estimation, now the next topic is empirical estimation models. Uh, Empirical estimation models can be used to complement the decomposition techniques or offer a potentially valuable estimation approach in their own right. The model is based on the experience or historical data and takes the form d is equal to a function of f which is depending upon a variable called bi, where d is one of a number of estimated values such as efforts and cost or duration, and bi is a selected independent parameters like estimation that we have used, we studied like LOCs and FP. So this is a general approach where we actually create where we actually learn how to create more estimation based on the data we actually use in our previous slides like LOCs and FP. If somebody haven't has not used have not seen the videos on function point, pause it out. You can we are giving you a link of the function point matrix. You just click that, go and read the function point module, and then come back and continue this video. Now the basic formula, which is not d is equal to f times v f with the parameter vi, it can be expanded into a formula effort, like effort is equal to tuning coefficient multiplied by size raised to the power of exponent. So this tuning coefficient might be different for different things, right? This tuning coefficient can be what you can say. This tuning coefficient is depend upon the project. So this tuning coefficient actually has is depending upon what project. So what type of project you are working on, this tuning changes. Likewise, the exponent also depends upon the project, right? And this size generally is in LOC or the function point, right? So generally LOC means KLOC. KLOC is the default value of the size, and this can be effort or this can be the development time. Okay, you can have time also here, you can also have efforts also here. Basically these two things. Now, based on, as we have seen that the coefficients and the exponents depends upon the project. So the projects can be either organic, semi-detached, or the embedded. Uh, Barry Boehm was one of the leading researcher in the field of software engineering. He actually devised these three basic classification. And organic, the projects which are called as organic or semi-detached or embedded uh, can be explained like a project is called as organic if a development project has uh, is doing a well understood application program, or the size of the development team is reasonably small, the team is experienced in developing such similar projects. So we call those teams as an organic team, or this project as an organic project. Now, on the other hand, if the team that is going to implement a project is a mix of experienced and unexperienced staff, the team member have limited experience on the related subsystems or maybe unfamiliar with some of the aspects of the development, this is termed as semi-detached. And and the last part, if the project that you are going to develop is extremely dependent or tightly coupled with the hardware, it is known as the embedded project. So this is very clear approach, clear classification of these three type of projects. Based on the three different type of projects, you have those coefficient that we discussed in the previous slide. Okay, so either a project can be semi-detached, or the project can be organic, or the project can be embedded, right? So if you know all these things, we can go ahead. Now we can have a COCOMO based estimation, cost constructive cost model. COCOMO stand for constructive cost model. It was introduced by Barry Boehm, and it has three versions: basic COCOMO, intermediate COCOMO, and complete COCOMO. With all this estimation model, it requires software sizing informations like function point, lines of code, object points. We are not going to cover object points in this course. We will be focusing on function points and LOCs. And second thing is, we are not going to cover something called complete COCOMO as well, because it is much more complex and goes beyond the scope of the course. We will be covering in detail the basic COCOMO, this one, and some part of intermediate COCOMO, and we will try to complete intermediate COCOMO as a part of this particular course. Okay. Now, starting with the basic COCOMO model. The basic COCOMO model gives an approximation or approximate estimation of the effort and time. Okay, it says that the effort and time generally depends upon the lines of code. Okay, so the basic definition of the effort given by basic COCOMO and the time given by basic COCOMO is that the effort is A1 times KLOC raised to the power of A2 person month. Person month is the unit of effort, and TDEV is the development time. That means B1 is the coefficient multiplied by the effort that you compute in the previous stage, raised to the power B2, which is a coefficient again, and the months. The months is the unit of development time. Okay, so these are given, the where various values have been explained also. Now, what are these values? Because A1, A2, B1, B2 are coefficient, and I have explained this, that these coefficients are dependent on the projects, and we have studied the projects also. So, so the projects can be like effort for an organic type of system is this A1. This is A1, and this is A2. Right. So value of A1 is 2.4 for organic and 1.08 for organic. Right. For by putting these values, you can calculate the effort for an organic system. Likewise, if you know the coefficient for if the project is embedded, you will use a coefficient of 3.6 as A1 and 1.2 as A2, and you will put the value of KLOC in this value. Suppose it is given that the LOC value is suppose 1200, right, and the system is organic, right. In this case, what you will do, this A1 will be 2.4, okay, A2 will be 1.05, and what is the value of KLOC? The KLOC value will be 1.2. You will not use 1200 because it's talk about KLOC. Even if somebody is given you LOC, you have to use the value as 1.2. So the effort can be computed as 2.4 multiplied by 1.2 raised to the power of 1.05 in person months. So this is the value of effort, and the time will be, we will see the value of the time also. So if you have three different equations for three different values of effort, likewise you have three different values for the TDEV. The interesting thing is, for the TDEV, the value of B1 and is same. The value of B1 is same. Value of B2 changes. So the value of B1 was 2.5 and the value of B2 was 0.38. So if we come back here, the value of B1 was 2.5. So we have 2.5. Suppose this thing comes out to be X amount, right? So this is X raised to the power 0.38 times months. Whatever is this come from Y. So this Y is in months and X is in person months. So you will have these values here. So once you know about the development time, and so basic COCOMO actually says it out, and this is just an approximation. So it tells you about that approximately your code depends upon lines of code, and lines of code will give you the effort and time. But if you know the value of effort and time, you can also calculate something called like staff size. And if you know the value of effort, okay, and D is the duration, so in time, so you know the effort and time, so you can find out the duration also. Suppose the effort was X, right, and the time was y. So if we divide x by y, I will get the number of persons. So I will give the average size of the project, right? How many people will be required. Likewise, I can calculate the productivity of the project because I know the LOC value. The LOC value was 1 point, KLOC value was 1.2, and the effort was X. So when I put this, so I will get the productivity value in KLOC per month. So you can get this values as well if you know the project and you know the effort and time, right? So this was the question that everyone has to solve. It shows that assume that the size of an organic type project has been estimated 32,000 lines of code. Assume that the average salary of the software engineer is 15,000 per month. Determine the effort required to develop the software product, nominal development time, now the cost to develop the project. And suppose I also add it here that find out the number of persons required, number of persons, number of persons also that is required. Find this out, find this number of persons also in this, and then calculate the cost. Okay, change this, I change this question. So this is left for the users to calculate, because I have given you this, the project is organic, right? You have the formula for organic. So and also have given you the value of the LOCs, and I have given you the rate that you have given to the engineer per person month. So you can write it down, this question, pause it video, solve this, and give us the answer on the comment of this video. We will surely evaluate your answers and let you know whether you are right or wrong. And if you are wrong, we will try to reach you out and explain you the complete solution as well. So this was all about basic COCOMO, and hope you understand this basic COCOMO. We will see some more questions, some more topics on COCOMO, and then we will proceed with the intermediate COCOMO in the next video. Thank you.